Hi, today we're going to talk about section 6.3, and hopefully in chapter 6, when you're dealing with functions, it looks a little similar to our chapter 4 with the equations. Some different verbiage, but other than that, how we find things and what we're doing is pretty similar. A linear function is a function whose graph is a non-vertical line. So remember, vertical is straight up and down. So it's a straight line, just not straight up and down. A linear function can be written in the form of y equals mx plus b, which is exactly what we learned in chapter 4. And remember that m is where you plug in your slope and b represents your y-intercept. So example 1, writing a linear function using a graph. So look at your points. You're going to pick 2 points and find your slope. Remember, to find your slope, you subtract your y's, and then subtract your x's, and then you plug that in where m is in the equation. So they chose the points 2, 0, and 4, 3. So 3 minus 0 is 3, 4 minus 2 is 2, so they get the slope of 3 halves. Then to find your y-intercept, look at your graph over here, and you notice that one of the points is on -3. That's on the y-axis. So that's where it's going to cross at -3, which is why you see a -3 here. So the linear function is y equals 3 halves x minus 3. Example 2. Now we're going to write a linear function using a table. You can go ahead and graph out your points like they did over here to the left. They just graphed them out. If you don't want to do that, you can just pick 2 points on the table and find your slope. They chose -2, 7, -3, 9. They went ahead and subtract their y's, subtract their x's, and they got a slope of -2. Then you can find your y-intercept. So to do that, remember, look at your x values, and when x is 0, the y is your y-intercept. So your y-intercept is a +3. So when you plug those into your function, you get y equals -2x plus 3. Now we're going to try a couple here. You can either pause the video right now and try them on your own, or you can continue with the video and we'll do them together. It looks like it says use the graph or table to write a linear function that relates y to x. So if I look here, remember another way to find your slope is to take 2 points on a graph and you can find the distance between them. Remember, your movement up and down is your change in y, and your movement right to left is your change in x. So I'm going down 1, so that's a -1, and I'm going over 2. So my slope would be -1/2. Okay, and then to find my y-intercept, I see there's a dot on -1. So my y-intercept is -1. So I just have to plug that into my equation. So or my function, it would be y equals -1/2 x minus 1. Here's now number 2 is a table. I would usually start out by picking 2 points and subtracting my y's and my x's. However, when I look at this table, I notice that all my y's equal 2. So no matter what x is, y is always going to equal 2. So I'm just going to write that as y equals 2. All right, now on to example 3. You are controlling an unmanned aerial vehicle, a UAV, which I think is the same as a drone, for surveillance. The table shows the height y in thousands of feet of the UAV X minutes after you start its descent from cruising altitude. So y is feet in the thousands, x is minutes. A, write a linear function that relates y to x. Interpret the slope and the y-intercept. So again, same thing. You're going to take 2 points, subtract your y's, and subtract your x's. They chose 0, 65, and 10, 60. When they find their slope, they get -0.5. Then y-intercept, if you look over at your x's, 0, your y is 65, so your y-intercept is 65. So your function is y equals negative 0.5x plus 65. So what does that mean? So that means that your UAV is going to decrease 500 feet per minute, and it's going to start at 65,000 feet above. Next, we're going to go ahead and we are going to graph it. So at 0 minutes, it starts at 65,000 feet, and then it goes down 500 feet for every minute. So after 10 minutes, that would be 5,000 feet. So for every 10 minutes, it's going to go down 5,000 feet. Letter C. Oh, and we only used positive x's because you can't really have a negative time. Letter C. Find the height of your UAV after 1 hour. Well, remember x equals minutes, so we got to convert 1 hour to 60 minutes. And we're going to plug 60 in for x and then find out what y is, since y represents the height. So once we do that, we get 35. So the UAV will be at 35,000 feet after 60 minutes. So number 3, what if you double the rate of descent? Repeat parts A through C. So if this is our equation, y equals negative 0.5 or negative half x, if I'm going to double that, I'm going to get negative 1, right? So y equals negative 1x, or just negative x, plus 65. So that's going to be my new function. Letter B has us graphing it. So if you look over here, again, I still start at 65 feet, so I'm going to put a dot at 65. But now it's going to descend 1,000 feet per minute. Okay, so after 10 minutes, it's going to descend 10,000 feet. So now for every 10 minutes, it should go down 10,000 feet. And then finally, letter C, where is it going to be after 1 hour? So I'm still going to plug 60 in for x, so minus 60 plus 65. So I get y equals 5. So it's going to be at 5,000 feet. And you can kind of see that here on the graph. Here's 60, and it's about halfway there between the 0 and the 10. So that would be 5,000 feet. All right, last example, number 4. Comparing linear functions. The earnings in dollars of a nighttime employee working X hours are represented by the linear function y equals 7.5x plus 30. The table shows the earnings of a daytime employee. So if you look at the daytime employee, get your change in y over your change in x. So it changes $12.50 every hour. So the nighttime employee makes $12.50 per hour. Or I'm sorry, the daytime employee makes $12.50 per hour. The nighttime employee, they give us the function up above, which is 7.5. So they make $7.50 per hour. So the daytime employee has the higher hourly wage. B, write a linear function that relates the daytime employee's earnings to the number of hours worked. In the same coordinate plane, graph the linear function that represents the earnings of the two employees. Okay, so let's take a look at that. So when you go ahead and graph those, where it intercepts is when they make the same amount for the same hours. So it looks like the red line is your daytime employees. The nighttime is the blue. Because the nighttime must get like a $30 incentive, they start up at 30. The daytime employee does not get that. But since the nighttime employee makes less per hour, its graph is a little flatter. So when they intercept is when they make the same amount. So at 6 hours, they make the same amount and earn the same, or if we're working the same hours. So the graph shows that the daytime employee has a higher hourly wage, but does not earn more money than the nighttime employee until each person has worked 6 hours. So yeah, after those 6 hours, then the daytime employee earns more. On your own. Manager A earns $15 per hour and receives a $50 bonus. The graph shows the earnings of Manager B. Which manager has the higher hourly wage? So Manager A makes $15 per hour. So we know that, $15 per hour. But now we got to look at Manager B. Well, if we know in 3 hours he makes $75, we just have to go ahead and take our y and divide it by our x. So 75 divided by 3, that gives me $25. It's the equal sign. $25 per hour. So Manager B is making more money per hour. After how many hours does Manager B earn more money than Manager A? So there's a couple different ways that we could do this. One way is to graph Manager A. So we could start with the $50 bonus right here, and then we could go up 15 each hour. So if I'm at 50, then it'd be 65 and so on, and you can connect the points, and then wherever it intercepts, then that's where it is. Or you could set them equal to each other. So I could do 25x, because he makes $25 per hour. When is that going to be equal to the employee A, which is $15 per hour, plus his $50 bonus? Okay, so then I'm just going to solve for x. So I'm going to subtract 15 from both sides. 15x. So then I get 10x is equal to 50. Then I'm going to divide both sides by 10, and I get x equals 5 hours. So at 5 hours is when they would work the same amount of hours and earn the same amount of money. All right, there you go. That is 6.3.